At number 13 in chapter 3. I didn't mean to grab the highlighter. So when I'm looking at this probability one, I always draw a chart. So my example says the probability that an animal will have orange fur is 0.58. So probability of orange is 0.58. And then it says probability of gray is 0.31. And that the probability of brown is 0.11. So what I do is think of it as a chart. So we've got our orange cats, we've got our gray cats, we've got our brown cats, and essentially this is saying that if there were 100 total, right, that 58 of them would be orange, 31 of them would be gray, and 11 of them would be brown. So notice that would add up to the full 100. But then it says further, we divide them into whether or not they have stripes. So I'm going to put the striped here and how about the not striped there. So mine says that if it's orange, the probability of stripes is 0.1. So that means the probability of stripes, if you know that it's orange, is 0.1. So if we know that it's orange, we're sitting in that first row right there, because that's where all the orange cats live. And it says essentially 10% of them have stripes. So what we can do is in our chart here, of the 58 orange, 0.1 of them will have stripes. So if I do 0.1 times 58, I'll get 5.8. So 5.8 of them have stripes, and there were 58 total, so that must mean that 52.2 of them don't have stripes. And so see, we can do the same thing for the other ones. So I've got that the probability of stripes given brown is 0.16. Well, I have 11 brown cats, so if I do 0.16 of 11, I'll get 1.76. And there were 11 total, so if that many have stripes, then 9.24 of them do not have stripes. And then for the last one, I'm going to come in here and erase for a minute. Let's just get rid of this piece. We don't need that. Actually, we won't need this anymore either. So the last one says that the probability of stripes, so if the animal is gray, the probability of stripes is 0.27. So the probability of stripes, if we know that it's gray, is 0.27, which means 27% of my 31 gray cats have stripes. So 0.27 times 31 gives me 8.37 of them have stripes. And if there's 31 total, that means that 22.63 of them do not. And so notice if I add up each of these individual columns, so I can add up 5.8 plus 8.37 plus 1.76, that means, oh, it's not fitting, 15.93 have stripes. So that goes right there. And then 52.2 plus 22.63 plus 9.24 would give me 84.07. So that is, so again, this value goes right here. This value goes right here, but it won't let me fit that. And notice if we were to add those two together, so that 15.93 0.93 plus the 84.07, we get that total of 100 cats. So we have everything in our chart, and we can answer now any question that they throw at us. So in the first part, it says, what is the probability an animal has stripes? So straight out probability of stripes. Well, 15.93 of them have stripes out of 100 cats. So essentially we're just moving that decimal over. So 0.1593. So that's going to be our striped animals, 0.1593. I think it said to round to 3 decimals, so I should just have 0.159. And then the second part says, what is the probability an animal is orange given it does not have stripes? So probability of orange given no stripes. So you see the known part here, the part that we know about is no stripes. So whenever you have a given like that, the part that you know, what that does is it narrows down your entire sample. So because I know for a fact there are no stripes, I am in this column and nowhere else on this chart. I am only in the not stripes or no stripe column. So because I'm in the no stripe column, the probability of being orange, well, there's 52.2 orange cats, and how many in that column total? 84.07. So if I do my 52.2 orange cats divided by my total number of no striped cats, I'm going to get 0.6209. So we're going to say 0.621. And that was just a tilde to say approximately 0.621. So that's how I like to do these questions, making a table and just make it out of 100. That way you can just turn those percents into numbers. So it just kind of makes a good visual and everything comes together. So that's it.